Dear friends, we are going to see RL series circuit where due to R we are getting voltage and current in phase, and due to L current lagging voltage by 90 degree. So current is the referring point, I is same through R and L. In the circuit you can see total voltage supply is divided into two parts, VR and VL. Due to Kirchhoff's voltage law, we can see V is equal to VR plus VL. So therefore V is equal to square root of VR square plus VL square due to same current, IR square plus IXL square whole square root, then I square root R square plus XL square is equal to I into Z. Therefore I is equal to V by square root R square plus XL square. Therefore that is equal to V upon Z. So from this phasor diagrams you can see the triangles of voltage and impedance. So here the phasor diagram and the waveform is for RL series circuit. Voltage is in 0 point where current is in lagging by 90 degrees, or that is phi degree. So therefore current will be Im sin theta minus phi, and where Im is Vm upon Z, that is maximum voltage upon impedance. So in this way we can calculate the waveforms and impedance. Whereas from this second phasor diagram you can see that P is equal to V into I cos phi, where part of current in phase with voltage, that's why it is cos phi, where Vi cos phi is what? R by Z. From this Pythagoras theorem for impedance triangle, therefore V upon Z into IR. So V upon Z is what? Current. Therefore I square R is the formula for power. And from this waveform you can see instantaneous value of power. From the voltage and current waveform we get the power waveform. So half Vm upon Im, that is maximum voltage and maximum current. So instantaneous value of power is calculated by this formula. So cos phi minus cos 2 theta minus phi, whereas cos 1 by 2 Vm into Im cos phi is the real part of the power, and 1 minus 1 upon 2 Vm Im cos 2 theta minus phi is the pulsating power, which is always 0. So power average is Vi cos phi is equal to Vm upon root 2 and Im upon root 2 cos phi. Therefore you can see power consumed by resistance, not by inductance. Vi does not give true power. V and I are not in phase as in DC circuit. Therefore apparent power, that is volt ampere, true power is watt, is equal to Va voltage ampere cos phi. Then what is power factor is the cos phi and cosine of angle of lead or lag, or voltage and current. So cos phi is R by Z, or watt upon Va. If multiplied by K, so kW upon kVA, that is active power upon apparent power, that is S. P by S. So DC circuits VI, and that is watt. AC circuit VA, that is reactive power, is, and active power, from this phasor diagram you can see W and VAR. So kW, kVA and kVAR. Reactive power is kVAR and active power is kW and apparent power is kVA. So from this triangle you can see PQS. P is I square R, Q is I square XL, and S is I square Z. So these are the two phasor diagrams for leading power factors and lagging power factors. So S is equal to, that is apparent power is equal to VI is equal to IZ into I square Z, VA apparent power, and the real power is P, that is I square R, is equal to VI cos phi, that is in watt. Then reactive power is Q is equal to I square XL I square Z sin phi, that is equal to I into IZ sin phi. Therefore VI sin phi is equal to VAR. So that is imaginary power. S is equal to square root of P square plus Q. So in this way you can calculate the active power, apparent power and reactive power.